we're going to finish 10.3. Make sure you have your Z table out and your calculator out.
So Z tables?
Yeah.
You're still using those?
We are. They're not going to go away. We're stuck with them.
Yeah.
And for part of today, I'm going to quote unquote put each group on pause, if you will. And so I'll let y'all know when I'm talking to which group. But you can listen to both sides of the story. But for a couple of problems, we're going to work on each the way dual credit wants you to work them and the way AP wants you to work it. AP, you're working the problems the same way as what's in the book. If you look in the book, dual credit, they're doing it a little bit different. They want you to, basically they're different methods. AP, we're going to do what's called the p-value method for all the problems. For dual credit, we're going to look at called the rejection region method. Now, for 7.2, even though it's not dealing with proportions, they'll still want you to use the p-value method a little bit. So I wouldn't just totally tune me out when I say, okay, let's solve it the AP way. Just kind of listen. Maybe you don't write it down, but I wouldn't totally tune me out.
Sure.
Okay. So yesterday we did the very first example for doing a hypothesis test with population proportions. Let's look at the next one. The report states that nationwide, 61% of high school graduates go on to attend a 2-year or 4-year college the year after graduation. Suppose a random sample of 1,500 high school graduates in 2009 from a particular state estimated the proportion of high school graduates that attend college the year after graduation to be 58%. Okay, so let's see here. As we go through, let's try to digest the information they give us. That way we're not like just overwhelmed at the end. Okay, so the report estimates 61%. Helps if this is turned on. Okay, the report says 61%.
Wouldn't that be the HO? 0.61?
Yes. Correct.
Would it be mu?
P. So our null is that P is 0.61.
Why is it P instead of mu though?
Because we're dealing with a population proportion. Mu is a population mean. P is proportion, mu is mean.
In the question, say that
Well, if we're dealing with,
say mean.
it would say mean or average or something like that. Yes. If we're dealing with percents, it's a proportion.
I mean, H alpha is going to be P is not equal to 0.61.
So the alternative is P is not equal to 0.61. That's right. Okay, so that's our null and our alternative. Now what is P? Yeah, no worries, David and Yusuf. So what does P give us? It's the true proportion of what? That's right. True proportion. I can't spell today. High school students who go directly to college. Okay. Okay, so what's this 1500 in the problem? That's our N. Let's make note of that. What about this 58%? That's going to be our P hat. That comes from our sample. And then, of course, they tell us use alpha as 0.01. That's all of our information from the problem itself. Now, before we solve these, we're going to have to check our assumptions. We got to make sure we even can solve it.
Repeat that again. Like, what does it mean?
P hat is the sample proportion. So in this case, it's the sample proportion of high school students who go directly to college.
What's the other thing, the 0.01?
That's our level of significance. That's alpha. Yep. So let's check our assumptions before we go any further. Now for AP, I'm going to need y'all to actually write as part of your solution that you check each assumption. So, okay, we stated that, we did that. So we would have to say, okay, we checked that given a random sample, we're given a random sample of 1,500 high school graduates. And then since 1,500 times 0.61 is greater than 10, and 1,500 times 0.39 is greater than 10, our sample size is large enough. Now, for dual credit, these 10s should be replaced with what? 5s. So, for dual credit, you'd replace the 10s with 5s. And these are blanks, so make sure you're filling in the blanks. And then population size is much larger than the sample size. I mean, I would hope that there's more than 15,000 high school graduates in the nation.
Hey, Mr. Schultz,
Yes.
that typical, right?
For dual credit, the 10 is supposed to be a 5. For y'all, it stays a 10. So all of our assumptions check out. That means we can proceed with doing the actual test itself. Didn't finish it. Okay. Got it?
Wait, I'm so wrong. My bad. What is it, 5 for again? Oh, I don't. For AP, right?
And the 5 is for y'all.
Oh, I thought we were.
Y'all are 5.
Okay. All right.
Got it?
Yes, sir.
Okay. So let's calculate the test statistic.
Can you just write that? Blank area?
Yeah, below the assumptions. Yep. I threw it up there. I really don't want it up there right now. It's actually, I want to do it together. So, test statistic. Okay. So Z will equal P hat. What was our P hat? 0.58 minus P, which is 0.61, divided by the square root of, I need to do P, so 0.61 times 1 minus P, which is 0.39. The reason I made a big deal of saying P is because on the test, a lot of y'all would try to do P hat right there. So down here on the bottom, y'all do P hat and then 1 minus P hat, and that's not right. Make sure you do P and 1 minus P. And then what was our N? 1500. If we calculate this to 2 decimal places, what would we get? Negative 2.38. That's right. Okay, so that's our test statistic. Where did my little mouse go? There it is. Okay, at this point, dual credit, I'm going to put y'all on pause. And I'm going to keep going with the AP way. Okay, so do we at least have the test statistic written down? That part down? Okay. That's about to look nasty up there when I go to the next part. There we go. I'm going to just erase those because this is bothering me. I can't handle it. Okay. Now, for the p-value method, what we want to do is look at the area that's more extreme than this. But notice, what kind of test is this? Is that not equal? It's a two-tailed test. What we want to do is figure out first, what's the probability that z is less than negative 2.38? So we need to look at our z table and figure out what would that probability be. If you have your textbook, the z table is actually in the back of it. .0087. That's the area in the lower tail. To get the area in both tails, we'll just multiply this by 2. Our p-value is 2 times .0087. Again, that's because this is a two-tailed test. 0.0194. Good. Okay, so now we need to compare our p-value to our alpha. All right. I have it right here in front of me, and I still wrote 4. Did you say 7.4 the first time, or did you? Okay. Okay, so let's compare this to our alpha. What alpha does it tell us in the problem we need to use? Alpha is .01. Is this bigger than alpha or smaller than alpha? The p-value is bigger. So since the p-value is greater than alpha, what would we have to do? I think back to yesterday. What did we say we had to do if the p-value was greater than alpha? We can't reject. Right, so how do we phrase that? That there's a certain way. Fail to reject. That's right. Okay, where did my mouse go? Oh, there it is. Since p-value is greater than alpha, we fail to reject H not. So that means the evidence does not suggest the proportion of 2009 high school graduates who went on to college, went on immediately to college differs from the national value. So our data does not suggest that. And yes, I'm writing on a terrible slant here. Now, since we failed to reject, what kind of error could we have made? I'm not saying we did make one, but what kind could we have made? Type 1 or type 2? Type 2, that's right. Since we failed to reject, that means we're either right or we made a type 2 error. Make sense? Okay, so this kind of just goes on to finish what we just said. I'm not saying we did make a type 2 error, but we could have. Now I'm going to put y'all on pause and look at dual credit. Dual credit, and I'm pressing play. Let's do this y'all's way now. And this is where that handout comes in. What I did was I printed off the slides for the two problems that I worked y'all's way, so y'all would have a concrete handout to like put your hand on and hold and look at when you're doing your homework. That's what that handout's really for. Okay, so again, we said this with AP. This is what kind of test based on our null right here? Sorry, our alternative. It's not equals means it's a two-tailed. Two-tailed. So on a two-tailed test, we need to find the z critical value so that there's alpha divided by 2 in each tail. In our case, alpha is 0.01, so 0.01 divided by 2 is 0.005. So I need to look on my z table and find where is the probability, so the number in the middle of the table, equal to 0.0050. And then trace that outwards to get your z-score. This is where your z-table comes in. So I want y'all to try that. So look in your Z table and then trace that value outwards. Wherever you found the probability at, trace it outwards to get the Z score. Negative 2.57, and it's right there in the middle. Negative 2.575. So our Z crit, negative 2.575 on the negative side. Remember, it's a two-tailed though, so we also have to have a positive 2.575. Okay, so once we get our Z critical value, erase this. Then we need to identify our rejection region. So let's entertain for a second what this looks like. And you don't have to draw this, you can if you think it would help you. You don't have to though. So here's our normal curve, here's our true P right here. Now, our Z critical, let's say this is our upper end. Here's the lower end. If I want to be in these two tails, and we found negative Z and positive Z, that's what we just found. How can I write an inequality that says I want to be in these two tails? Z has to be less than my negative Z critical, or Z has to be greater than my positive Z critical. So that's our rejection region. And what this means is if we find our Z statistic fall within this region, then we reject. If it doesn't fall within the region, then we fail to reject. Think of it like scoring a touchdown. If you end up in the end zone and it's the one you're headed towards, what happens? You score points. If you don't make it in the end zone, you don't score. So if we make it into the region, we reject. If we don't make it into the region, then we fail to reject. We do not convert the fourth down. Okay, so that's our rejection region. this so that way it doesn't muddy up the slide here. Or you can't read what's going on. Okay, and we've already calculated the test statistic before I put y'all on pause, quote unquote. So the third step would be to compute the test statistic.
We already did that though.
We already did that though, yeah. So now we gotta look, does our test statistic fall in the rejection region or does it not? So is negative 2.38 less than negative 2.575? No. Is it greater than 2.575? No. So does it fall in our region? No, it doesn't. It's not in the region, which means we don't make a touchdown. So we have to fail to reject. That's right. So the negative 2.38 is not in the region. Excuse me. So we would fail to reject the null hypothesis. This means there's not enough evidence to support the researcher's claim. Questions on this one from the dual credit side? Or even AP? I mean, are you listening? You're like, so why did we do it this way or that way? What I will say is for the 7.4 homework dual credit, this is the way your whole 7.4 homework will go. You won't do the p-value method for 7.4. What? Okay, next example then. So on to the next page. Now, this next example, I didn't split up into dual credit versus AP. We're all going to work it the same way. Like I said, eventually dual credit, you'll have to know the p-value method anyways. We might as well get familiar with it now, so it's not a complete shock to you. Okay. This problem's a little confusing, so make sure you pay attention closely to the wording. A county judge has agreed that he will give up his county judgeship to run for a state judgeship unless there is evidence at the .10 level that more than 25% oppose him. So if more than 25% oppose him, he's not giving up his county judgeship. A random sample of 840 members included 217 who opposed him. Use statistical evidence to advise the judge. So he's depending on us to tell him, would it be smart to give up his seat or not to run for state judge? Okay, well, let's see. What's this .10 right here? .10 level. What does that mean? What letter would that be? It's alpha. Good. That's our alpha. Okay. Then it says more than 25% in opposition. So this more than 25% would give us our what? Greater than 0.25. Which hypothesis would that be?
That would be the alternative.
That would be the alternative, good. Let's make note of that down here. Our alternative is that P is greater than 0.25. So what would the null have to be then? Less than or equal to. So for dual credit, that's what you'd put. What would it be for AP? Equal. Okay, so there's our null and our alternative. Now keep in mind, P is the true proportion who opposes the judge. Okay. So now, before we go any further, we need to make sure that we can do the test. Which means we have to check our assumptions. So, let's kind of run through them. First, does it come from a random sample? Yes, it says a random sample of 840 members. Okay. Second, is n times p greater than or equal to 10 or, in dual credits case, 5? N times p, yes. 800 times p, which is 0.25.
Yes.
Yep, that's 200, which is definitely greater than or equal to. We could even say 10. I mean, if it's greater than 10, it has to be greater than 5. Okay, let's check just to make sure n times q, which remember is 1 minus p. Which would be 600. That's certainly greater than or equal to 10. So is our sample big enough? Yes. Okay. And then the third one was that it can be no more than 10%. Well, I bet that more than 8,000 probably live in that county. So we've checked all the assumptions. They're all valid. We can move on to the next phase. can actually calculate things. So now let's figure out, let's see, what was our n? What did we say n was? 800. What about p hat? 217 over 800, which equals what? .27. Let's just write the whole thing. Point. Yeah. 0.27125. Okay, there it is. Okay, so from here, now we can calculate our statistic. Z equals E hat minus the P that we're testing. Then we have a huge square root here. E times 1 minus P over our sample size, which is 800. When you calculate that, what would you get? $1.39. Okay, so now I'll need to find my p-value. Now this is what kind of test, if it's greater than. So one tail, which tail? Right tail, right. This is a right tail test. But I want to find the probability that Z is greater than 1.39. Now, does my table, my Z table, give me greater than that? No, it gives me less than. So I need to do 1 minus the probability that Z is less than 1.35. If we look at our table, what would the probability that Z is less than 1.39 be? 0.9177. So 1 minus that gives us 0.823. Where my notes go? This is called our p-value. Now, what was the alpha we had to use? 0.10. How does the p-value compare to the alpha? It's less. So since the p-value is less, what can I do? Reject H0. Which, since I'm rejecting H0, that means there is sufficient evidence to support the claim that P is greater than 0.25. Okay, so if this is the case, if there's evidence to support this claim, how should we advise the judge? Should we tell him to run or not run? Not run. He said if it's more than 0.25, he won't run. So we need to say right here that we need to advise him not to run. Okay, questions on this one? Still see some writing. Oh, hold up. Okay, next one. So in December of 2009, a county-wide water conservation campaign was conducted in a particular county. In 2010, a random sample of 500 homes was selected, and water usage was selected for each home in the sample. Suppose the sample results were that 220 households had reduced water consumption. The county supervisors wanted to know if their data supported the claim that fewer than half the households in the county reduced their consumption. So they did this campaign. Essentially, what they're wanting to know is, did it really work, or did not even half the county participate? That's what they're wanting to know. So what is their claim? And the last sentence kind of tells you. Less than half. Good. So would that be our null, or would that be our alternative? That's right. What would the null be? Yep. For AP, it's equal to, that's right. And what is P? What's P equal to? Or what does P stand for? The true proportion of households that reduce consumption. Okay, so before we proceed, we need to check our assumptions. So does this come from a random sample? Yes. Is that random sample large enough? Let's see, what is 500 times 0.5? 250. Yep, that's definitely big enough. The other one would do 0.5 again, you get 250 again. So yes, it's big enough. And surely there's more than 5,000 in the county. So yeah, we're good on assumptions. That means we can take it to the next step and actually compute, or computing our Z statistic. But to do that, I'm going to box these in here. I wouldn't do this on your paper. I just want to separate them from the rest of the writing. What's here? 500. If I get P hat, what would I do? 220 over 500, which gives me 4. Perfect. Now let's calculate the Z statistic. So which one comes first? P hat, so 0.44 minus T divided by the square root of what? 0.5 times 0.5 divided by 500. What would that equal? Negative 2.68, good. Okay, so there is our Z statistic. Now, we're going to finish up the AP weight and then come back and do the dual credit weight. While we're doing the AP weight, dual credit, I want y'all to see how far y'all can get on y'all's method. It's just like we did on knowledge attendance problem. Okay, so since we're using, or we're needing to find p-value, what kind of test is this? It's less than, so I need to find the probability that Z is less than negative 2.68. So that's where our Z tables would come in. If I look this up in the Z table, I would get 0.0037. Now, I don't have it up here on my screen, but what alpha do they want us to use? 0.01. So how does this p-value compare to our alpha? It's less than. So p-value, since the p-value is less than alpha, what would we do? We reject.
Isn't that the same way for our stuff?
Yes, but y'all are dealing more with, when we do it y'all's way, y'all would be dealing with Z critical values. So you would find the Z critical value, get the rejection region, and see if it falls in the rejection region. You should still reach the same conclusion. You're just using a different method to get that conclusion. Does that make sense?
Yes, sir.
Okay, I'm going to go to the next slide that formalizes everything that we just did here. Okay, so like I said, it's just formalizing what we said on the previous slide. So since we reject H naught, that means there is convincing evidence that the proportion of households with reduced water usage is less than half. Now, since we rejected H naught, what kind of error could we have made if we made one? It's a type 1 error, that's right. Not saying that we did make one, but it could be a type 1 error. Okay, let's finish up today by looking at the dual credit method of doing this. So, what kind of test is this? Left-tailed, right-tailed, or two-tailed? It's a left-tailed test. Perfect. So we need to find the z critical value so that alpha equals 0.01 is totally in the left tail. So what z critical value would give you an area, or sorry, a probability? If you look in your table, 0.0100. What z would that be?
-2.33.
Negative 2.33. Perfect. So now we need to identify our rejection region. Well, what would our region be to reject? If our calculated z is what compared to negative 2.33? Let's draw a little sketch here. So here's my graph. Here's negative 2.33 right here.
Z is less than negative 2.33, and therefore Z is greater than negative 2.33.
Just the Z is less than.
Just the z is less than. We won't tell. So z has.
This one was two tails over here.
That's right.
I got you.
Z has to be strictly less than, I should say equal to here, negative 2.33. So that's when we'll reject. Now, we already calculated before I saw for dual credit. We calculated the test statistic, right? Z. So we got negative 2.68. So does that fit into our region here? Yes, it does. It fits nicely in there. So since it's in the rejection region, what does that mean? We reject. We would reject it. We would reject H0 and conclude that there is enough evidence to support the claim. Remember, our claim was what was stated in the problem. Less than 0.5. Okay. That's it for today. We're going to stop here. For those of y'all that joined us late, I pushed everything back on the calendar today. So AP, it should already be synced with Google Classroom if you go by like that checklist that I upload every 2 weeks. Recheck that. I've pretty much moved everything back a day. Dual credit, I need to update Blackboard. I'll do that this afternoon with the updated checklist. So as far as what's due, AP, your 10.3 homework is due tomorrow. 10.4 is getting all the way pushed back to Friday. No, Thursday. Not Friday. Thursday. Dual credit, 7.1 is due today. 7.4 is due Thursday.